Well, hello there, and welcome to my video on Git installation for Windows. In this video, we'll be showing you how to install the Git source code management system on Windows 7. Git is a distributed revision control and source code management system. This video will not go into detail describing how to use Git, but rather how to install it on your Windows development machine. Other videos will discuss the benefits of Git, how to use it, and how to set up your development system to be both efficient and secure while you're using it. Here is the Wikipedia article on Git, if you're interested. To obtain the Git software for Windows, you will need to go to this following URL and download the current Windows installer. To save time, I have already done this and started up the installer, as you see here. We will start by clicking Next to begin the installation. This is the information on the public license for the software. You'll have to click Next. You will want to select the destination where you want Git installed. Personally, I would recommend this location for now. And then we will have to select components. My personal recommendation is to leave the settings as they are here, or change them to do so. Click Next. We will need to click the Start menu. Go ahead and do so, and if you choose not to select the Start menu, click this button. Click Next. And on this screen, I would highly recommend you leave the option as is to use Git from the Git Bash only. And then in the future, if you decide you understand Git and want to integrate Git and the basic Unix command line tools such as ls into the Windows command prompt itself, select this option. But for now, we will stick with using it from the Git Bash only. Click Next. And on this screen, I highly recommend that you leave the settings as is. This determines the line ending system that your files will use when they're pulled from remote repositories and committed to remote repositories. I would leave this as is, and then it will install. When you start Git, you will want to open up the Git Bash by clicking on the Start button, in Windows 7 at least, and then typing Git Bash to open up this program. This is the Git Bash. Once you install Git and once Git is installed, you'll be able to start what's called Git Bash. I highly recommend using the command line tools for this to start with. It will make things much more clear while you're learning how to use Git. Once you have Git installed, you'll be able to start what's called the Git Bash, and it'll open up the window you see here. Yours will vary slightly based on what version you're currently running, the name of the user you have currently logged in, which mine is example in this sample machine, and the machine name, Dragon in this case. You have access to basic Linux commands such as ls, ls-la to list more information, pwd to show your current directory, and other commands such as those. Clear will allow you to clear the screen and show you what you have currently available. You can extend the screen, type the same commands, and it will show you all the information. You can type clear. These are basic Linux commands. You should be able to easily learn and use these at will. So we will start off by showing Git. Type Git and we'll show you the help page on how to use Git. So currently we are in my user directory. I currently have, as you can see, I'm in under my root directory of my users folder, because example is my username on this machine currently. I personally have a different directory where I store all of my code. In the Git shell, you are able to use your basic Linux commands. pwd will show your current location, and I personally have a location where I store all of my code. This is under the C directory in a folder called code. Simple enough. So in this directory, I will go ahead and do what is called make a directory, mkdir. That command will allow me to make a directory. Directory and folder are generally interchangeable in this regard. So I will use generally directory, but folder is essentially the same thing. So I will make a directory, call it CS282, hit enter. I will go cd cs and hit tab. Autocomplete will finish that directory name for me. I will hit enter. And now I am in my CS282 directory. Do ls, you don't see anything, ls-la. That will show you two directories. Period is the current directory you're in, and period is the directory above you. So cd period will take me back up to code. Cd is change directory, by the way. Cd to cs, hit tab, it'll autocomplete. I can go back to the directory I was just in. This is just a basic introductory to Linux commands in case anyone is not familiar. I just realized I didn't explain the ls command. Ls is short for list. It will list the files in your directory. Ls man does not exist. Man is a manual for Linux, but ls-l will do a list of the total files in a more detailed version. ls-a will give all files, including hidden files, which in Linux, hidden files start with a period. And when you combine them, you get this, a detailed description of every file, including the hidden ones. So you'll want to know what those commands are. Okay, I've just cleared the screen, and right now we are still in the CS282 directory. We will go back up one directory, and I will show you how to remove a directory. RM is short for remove, -R is recursive, so if you remove a folder, it will remove all of the files recursively in that folder. And now CS282, the directory no longer exists. At this point, what we're going to go ahead and do is create your private public key pair for SSH. SSH is short for Secure Shell. I'll bring in the application that we'll be using. It's called Putty Key Generator. You can obtain Putty Key Generator from this URL, and it is right here called puttykeygen.exe. Putty Key Generator is nice because it simplifies key generation for Windows. We will go ahead and change this to 4096 because there's no reason to use more insecure keys. We will click Generate, and we will move our mouse randomly in this box down here. Moving our mouse randomly in that white area will help provide some randomization to the key generation process, thereby ensuring that we have a truly secure generated key pair. SSH, Secure Shell, requires both a public and private key. Discussion of the nuance of public and private key is beyond the scope of this video. However, you will load your public key onto remote servers and keep your private key on your development machine so that nobody else can get your private key. If you lose your private key, you will have to throw away that public-private key pair. This key that I just generated will not be using personally other than for demonstrations in this video, but I will describe the parts that you will now see. This here is the actual key itself. It's a random collection of zeros and ones, then converted into strings so that we can easily copy and paste it. The fingerprint of your key is a short version that is unique to your key and enables you to easily determine which key you're using when you have multiple keys on a system. For this video, I will be skipping the key passphrase. However, you will want to enter a phrase in here that you will be able to remember, and every time you use this key, you will need to enter this password here. This will enable you some leeway in case your private key gets stolen, because the person who wants to use your private key will then have to decrypt your passphrase first. This gives you time to replace your public key on any machines that were using it, so that once they decrypt your passphrase, your public key is useless. But for the purposes of this video, I will be using this blank for now. We will then want to go ahead and export our key. It will warn us about the passphrase. That's fine. And we will want to go to document, cancel, conversion, export, yes, C, users, example, and at this point we'll want to export our key to open SSH format. The key itself will be exactly the same, it's just the format in which the key is saved in that is important at this point. So we'll go ahead and save it without a passphrase just for this video. And we will want to save this to the desktop. And we will call this ID RSA. No, nothing else after that. And we'll click save. We will move this off to the side. And now, once that key is saved, we will go to our GitLab account. I will not be describing how to create a GitLab account. You can use any one of these services or sign up manually yourself. And once you have your GitLab account created and verified, go ahead and sign in. Go to your profile settings. Go to SSH keys. I've been making a bunch of keys for preparing for this video, so you will go to add an SSH key. Mind you, again, that is profile settings, SSH keys, add SSH key, and what we will call this is, you will call this key for your development machine. So if it's your laptop or whatever the case is, you'll want to name that there. You can have multiple keys here, and I would highly recommend that actually, so that if you lose your laptop, you can just delete your laptop key and your key on your, let's say, desktop at home would still work fine. We will come back to the Putty Key Generator. We will select all of this text, copy it, paste it in here, and select Add Key. And you'll notice the fingerprint here matches the fingerprint there. And when that is correct, you can go ahead and go back to SSH keys, and you will see your key now exists. The point of adding an SSH key to your GitLab account is that it enables you to securely communicate between the GitLab server and your machine, so that nobody can eavesdrop over your communications. Go ahead and click back on your dashboard, which is this icon up here. Click New Project. You won't have any of these. These are just projects I already have existing. And you will want to create a project name. So we'll actually import an existing repo. Come over to Professor Schmidt's website, Git account website, I should say, and you will go ahead and grab this URL right here for HTTPS clone. You'll come back to the GitLab account. You'll paste it in there. Call this CS282. A namespace, ignore that for now. We can ignore that also. And Vanderbilt CS282 private repo. And we will keep this private. That's the point of GitLab over other options such as GitHub, is that GitLab enables you to have private repositories so that no one will be able to steal or look at your code, and that this option provides you safeguards for the academic honor code. Create project. What now is currently happening is this command is being ran on the remote server, and it is cloning the repository from GitHub to GitLab in your account as private, so therefore you can make changes to it at any point. And what we will do is you will see this command up here under SSH. Once you have this here, we will go back to Windows and I will find the directory. There we go. So here is my users directory in Windows. There is a folder in this directory called .ssh. However, you can't see it right now, and so what we'll need to do is press Alt, go to Tools, Folder Options, View, Show Hidden Files and Folders, Hidden Files, Folders, and Drives to be exact, and unclick this. Hide extensions for known file types. So this will show you the actual file extension of software. Once you're able to see hidden folders, you'll now see app data. We'll go back to the Git shell. Go make directory.ssh. The .ssh folder appears. And we will copy over into this directory the key that we created earlier. This will enable us to use secure communication through GitLab and our local machine. I'm going to change back to the code directory and type git clone paste in the Git URL and hit enter. And you'll notice that the authenticity of this host, and hit enter. You will notice that when it starts cloning CS282 repository into your code directory, that it will warn you that the authenticity of the server is not known at this point. That is correct, because the server, you've never connected to this server before. Are you sure you want to continue? Yes. It has permanently added GitLab to a list of known hosts. And for your own information, the known hosts is this file here. You don't really have to worry about it so much manually editing it, but just knowing that it exists. it lists all of the servers that you've connected to and what their unique fingerprints of their key is for SSH. So we have now successfully cloned the repository from Professor Schmidt's repository on GitHub to a repository of your own on GitLab. This will enable you to keep a remote location for all of your source code, so that way in case anything happens to your development machine, none of your work will be lost. And then you will also have your version of the code let's see, what is it called? CS282. And now you'll notice that it's called master under CS282 because that means you're on the master branch. Branching and those topics will be discussed in another video. Type ls and you now have the entire clone of the repository from GitLab in your local machine. Okay, now that we are currently able to pull our repository from the GitLab account down to our local development machine, we have one major last step to go through. We need to go to settings for our repository, and we'll see that I'll restart that. We'll go to our repository, click on settings, and then members. In here I have myself, obviously, and we'll add a new project member, developer. You will need to go ahead and add the TAs for this course. I currently only have 2 of their names, so I will just show you one of them, for example. And in an email, you will receive the additional names that you will need to add as developers for your private repository. The TAs will not be pushing information to your repository, but they will be pulling it, and this is how you will both submit your information for the TAs to review and the final submission. I will only be showing you one of the how to add one user. Nolan. You can add the list in, but I will just be showing you how to add the one. You'll add developer, and Nolan is now a developer on my project. This you will receive by email the full list of names that you will need to add as private to your private repository as developers, so that the TAs can pull your code and examine it for your final grade for each assignment.